Hello, everyone. Thank you so much for joining us. We'll start the presentation in about 1 minute. We're waiting for people to get in and get settled. Thank you once again. Hello, everyone. Once again, we'll start the presentation in about 30 seconds. Thank you once again for joining us. Hello, everyone, and welcome to today's Safety and Health Magazine webcast, Clearing the Air, Mastering Weld Fume Management, sponsored by Miller. This is Alan Ferguson, Associate Editor at Safety and Health Magazine, and I'm moderating today's event. Thank you so much for joining us, and before we get started, there are a few housekeeping items. As a disclaimer, the views of today's speakers are their own and do not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise product or publication does not mean the council or the magazine endorses those items. After today's presentation, we'll conduct a question and answer session with our speakers. If you have a question, click the Q&A button at the bottom of your screen, type your question, and press the send button. We welcome your question at any time during today's event. You don't have to wait for the Q&A to begin. We might not get to every question, but the good news is unanswered questions will be forwarded to today's sponsor. Also, after this presentation, you'll be asked to complete a brief evaluation survey, and I'll tell you more about that a little bit later. Just to let you know, this webcast will be archived so you can access it after today's live event to view this webcast and all of our past webcasts. Please visit safetyandhealthmagazine.com/events, or you may also receive a link in our post-event email. We'll also have a live demonstration during today's event. And for optimal viewing, please switch your view mode in Zoom to speaker mode, and the view mode should be in the top right corner of your screen. With that, let's introduce our speakers. With us today are Bert Schiller, Kathy Abshire, Marshall Legg, and Eric Summers. Bert is a certified industrial hygienist with more than 40 years of experience in a wide variety of industries. He's worked with Michigan OSHA and teaches at the University of Michigan School of Public Health. Kathy is the Safety Solutions Manager at Miller and is recognized by the International Safety Equipment Association for her more than 35 years of occupational safety and health experience in a variety of manufacturing industries. She works with customers across the North Central and Western Great Lakes regions to identify the best solutions for the welding applications and specific environmental and safety needs. Marshall is the product manager for fume extraction products, including all mobile, stationary, and centralized systems at Miller. He works directly with welders and Miller engineers to identify end user needs and develop innovative solutions that address and meet those needs. Eric is a product manager for all respiratory products at Miller. He has more than 15 years of experience with Miller safety products, particularly in helmets and respiratory products. Eric frequently works with welders to address their concerns and needs and develops respiratory solutions to solve them. Again, we thank you all for tuning in this presentation. Kathy, whenever you're ready, go ahead and take it away.
Thank you, Alan. Welcome, everyone. I hope you're all staying cool this afternoon. We've got a great session planned for you today. So whether you're at the beginning of your journey or already in process of mastering welding fumes in your manufacturing environment, this session is going to provide you with a solid framework to establish a strong fume management program. First, we're going to explore the nature of the welding fume particulate and understand the implications of exposure factors. Then we'll provide you a step-by-step guideline utilizing the OSHA hierarchy of controls to help you evaluate your weld environment and how you can implement these control methods to reduce welding fume exposures. Our team is then going to provide several innovative systems and solutions that have been proven in effectively managing, capturing, and protecting welders from fume exposures. And today, like Alan said, we're really excited to have the opportunity to bring to you live demonstrations of these systems directly from our Weld Fume Lab in Appleton, Wisconsin. So if you're ever in the area and you'd like to tour that facility in person, please reach out to us and let us know how we can schedule that for you. We'll have time for your answers and questions. So as Alan said, please make sure that you put them in the chat room following each of the presentations. However, before we begin, we have one important note to bring to your attention. Every weld environment is different and needs to be evaluated by a qualified industrial hygienist to determine the appropriate course of action for fume controls. This presentation is intended for the awareness and introductory purposes only and should not be used to replace professional consultation or complete review of the owner's manuals. At this time, I'd like to introduce Bert to provide us with a weld fume overview and understanding why its implications are important in managing exposures in the welding environment. So Bert, what are the basic elements we need to know in order for our audience to master the welding fume process?
Well, thank you very much. As you all probably know, welding fumes consist of various metal oxides generated by either the metal being welded upon or the welding consumable itself. The metal being welded on, if it's typical mild steel, the predominant component of the welding fume, of course, will be iron oxide. But there are other trace ingredients that may be generated. For example, if you're welding on galvanized metal, you're going to have a higher level of zinc oxide. And most importantly, if you're welding on stainless steel, you're going to be generating hexavalent chromium, for which OSHA has generated a standalone standard, which is quite rigorous. The welding consumables or electrodes themselves also give off metal oxides. There's a variety of these, and typically labs analyze for 12 or 13 different metals. The most important components of the actual electrode or the consumable, the most important one is manganese. Again, there's been a drastic lowering of the exposure limit for manganese, and it's tough to meet that limit unless you have good controls. We're going to be talking about some of these exposure limits and the different types of welding in a minute. Thirdly, though, there can be coatings present on the base metal. For example, if it's very old, if you're doing a demolition project, for example, and you're torch cutting or welding, you may have very old paint, which could even include lead. So you have to be concerned about what coatings might be on the piece of metal you're welding on. Type of welding process. We're going to talk about these a little bit more. There's MIG, TIG, stick welding. There's also some that are a little less common. Sub-arc welding is a great process, gives off very little fume, and it's a good alternative. We're going to be talking about the hierarchy of controls in a minute, and substituting one welding process for another is a good way to reduce fume exposures. I've already talked about base metal and filler metals. Location. Obviously, this is important. If you're outside doing construction or demolition work and there's a good breeze going, you're going to probably have less exposure, unless, of course, it's blowing the fume right back into your face. If you're indoors, you have to still have good general ventilation. You have to be careful if you're welding in an enclosed space, such as a box or some kind of a tube, because it can give off quite a bit of fume and you have to be careful. Worker work practices. I've run into welders that are nearsighted and they bend over to an extreme ascent so their head is right directly in the welding plume. So it depends upon the welder himself, what his vision is like, what he's used to doing. So it's important to observe what kind of practices are being followed. It's important to have good general ventilation in a room. It's even better to have local exhaust ventilation, and we're going to be talking about that at length in a little bit when we get into the use of the various ventilation controls. Why weld fume management? Well, there's a couple of reasons. I'm going to start out with the bottom left. Proper weld fume management increases safety and health. Obviously, this is the predominant concern. We want to protect the health and well-being of the welder. But there's some other issues. Compliance. Over 2,100 businesses were cited for respiratory violations in 2022 by OSHA. Maintenance. The facility will stay cleaner, potentially reducing cleaning and maintenance costs. And if you have a good, healthy workforce, it's also going to increase productivity. There's a fifth reason that's not on this slide. I may add it, and that's workers' compensation costs. You can reduce substantially your worker compensation premiums if you have effective welding fume controls. How to assess your air quality. Now, this isn't a commercial, but it's a good idea to retain a certified industrial hygienist to perform a worksite analysis. If you can't get an actual CIH to come out, you could get a experienced loss control professional from your insurance company or other consultants. But it's important on the onset to at least have oversight, if not direct involvement by a CIH. That person can test the air quality in your facility, and he can assess where the contaminant levels fall within exposure limits. Due to some recent experiments we've done recently, we've shown that welding fumes can spread widely through an environment, even 15, 20 feet away from the source of the weld plume. You could have relatively high levels of metal oxide contamination. So an industrial hygienist can assess where the contaminant levels fall, and he can help to recommend good control strategies. I think, Kathy, were you going to handle this one? If not, I can talk about it. These are some of the exposure limits associated with the different metal oxides. You see aluminum, beryllium. You'll see hexavalent chrome about halfway down. You'll see the exposure limit 0.005 milligrams per cubic meter as a time-weighted average. For both OSHA is actually lower than the ACGIH TLV. Usually the TLVs are more conservative than the OSHA limits, with a couple exceptions, such as for hex chrome. You'll see manganese on there, for example. Manganese still has a very old, somewhat outdated exposure limit. It says they're 5 milligrams per cubic meter as a ceiling limit. A ceiling limit means you shouldn't be overexposed even for a few minutes, which is, in the case of manganese, difficult to achieve. The more current threshold limit value, based on more recent research, is 50 times lower than the OSHA limit. And you'll see that demonstrated on the size, which shows the manganese exposure regulations. Kathy, did you want to make a comment on this one?
What I wanted to mention to our group here today is that there are several states that have adopted the ACGIH threshold limit values as their state programs. There are approximately 22 states within the United States that have reduced their exposure limits according to the ACGIH. So you want to make sure that you know where those states are, as depicted by this map, where those lower conservative regulations are enforced.
You can go online to check those limits if you don't have a handy resource in your offices. So next, you want to determine your action plan. You want to implement controls to create a cleaner, more comfortable work environment and to decrease compliance risk. To determine your action plan, you should follow the OSHA hierarchy for weld fume control. The first one of these is process modification or substitution. Secondly, engineering controls such as local exhaust ventilation. Thirdly, work practice controls. And lastly, on the hierarchy of controls is personal protective equipment.
Well, thanks, Bert. That was a great introduction to our session today. and a great basis for building a solid framework for a weld fume management program. As Bert mentioned, we are going to cover each step of the OSHA hierarchy of control very briefly, and then we'll get into our live demonstrations. So the first step, process modification substitution, which is what I will cover. The objective of this method is to eliminate or minimize the exposure before it can occur. And relative to the welding industry, there's a few ways of being able to do that. Modifying the welding process by changing or implementing the weld process itself, maintain better weld parameters, and perhaps automating the welding application if that's possible and feasible. Changing your base metals to lower manganese content in the filler metals, using higher purity of shielding gases, or possibly changing the base metal if that's feasible. Keep in mind that some of these changes and modifications to the processes might require recertification of your weld procedures and retraining. It's important to document all of your process modifications and any attempts you have in trying to reduce your weld fume exposures to see which is the best result in improving your environment. One thing, though, is understanding the complete landscape of the fume generation rates is important. So when you're selecting the welding process and the type of shielding gas to be used in your setup, studies have shown that there are certain processes that generate more fume generation rates or higher fume generation rates, and shielding gases that actually reduce fume generation rates. So for example, flux core welding with 100% CO2 has the highest fume generation rate, but modifying that with a mixture of argon and 25% CO2 drastically lowers that fume generation rate. So be cognizant of the process that you're doing and the type of gas you're using when we're talking about fume generation rates. Now, with every modification, there are advantages and disadvantages. So changing a process overall, reducing fume exposures are going to help improve safety and compliance of your environment. And changes can be targeted for specific constituents such as manganese and hexavalent chromium to reduce those particular exposure levels. And some modifications, such as changing gases, are relatively simple to implement, and you'll see immediate results. Some key considerations are those that some of these changes may require an investment in new equipment or gases, and higher purity gases are typically more expensive than others. And changes in these processes may require additional time and training and recertification. Not all processes will work in all situations. So as Bert had mentioned, outdoor applications certainly are a little bit different and require other considerations such as temperature and wind direction than indoor applications. However, either way, make sure you're documenting your progress. Now, if these changes are not feasible in achieving the levels of compliance that you require in your facility, no worries. There are additional steps that can be taken to further reduce exposure levels to welding fume. But if you have any questions about process modification, please enter them into the Q&A box and we'll address those questions later. So now let's move on to the second step of the OSHA hierarchy with Marshall Legg. So Marshall, if the efforts of modifying the welding process have not achieved lower levels, what other control methods are available for our audience to consider?
Yeah, great. Thank you, Kathy. The next step in the hierarchy of controls, step 2, is engineering controls. So once you have maximized that first step, the next step is to move into a physical change in the workplace. Now, the goal here is to capture the fume that is being generated near the source so it does not enter the operator's breathing zone. And this can be done by a myriad of solutions. Two of the most frequent are fume extraction machines, either mobile or stationary, as well as local exhaust ventilation systems, like a standard centralized system, a large machine that's hooked up to ducting to various locations. The ideal environments here really range the gamut of applications, whether you're a school or a training facility, general manufacturing, even automation and fab shops, especially apprentice and labor unions as well. Here's a few examples of the categories of those fume extraction machines that we discussed. High vacuum starting on the left uses a small diameter hose and a high suction or high vacuum to evacuate fumes and capture the fume near the source in some different environments, maybe a small repair area, or in an area that's more confined where you need to get fume extraction into a small area to capture. Mobile systems, moving to the right there, are really versatile for the manufacturing environment that needs some versatility in how they capture that fume and where they position their fume capture, whether it's around an operator's table or maybe another fabricating environment that has larger weldments and you need to be able to move that fume capture to a certain location. Stationary systems are great for those areas that have a dedicated operating area that needs fume extraction consistently at a certain area. Various arm lengths can be attached to that, and you can obviously put that stationary system in various locations as well. And then finally, a centralized system. As we discussed, that is the larger fume extraction system that is dedicated to a facilities area that can be designed specifically for that area, whether it's small weld cells or weld booth areas like in a training facility, or a larger industrial environment that may have some hoods over automation cells or other larger training areas. These range from heavy equipment and heavy industrial applications, light industrial, as well as personal users. Now, what all those machines have in common, again, as they capture the fume, is that it filters that fume out. So every one of these machines should have a MERV rated filter. Now, MERV stands for that minimum efficiency reporting value. And what that does is a scale that helps grade the efficiency of that filter. Common filters will have a 7 to 11 MERV rating. Sometimes in a furnace in your own home, you might see a MERV 11 to 13. But these Miller Filtec XL filters are actually rated at MERV 15 or higher to make sure that we're maximizing the efficiency of capture. One of the critical technologies that helps us do that most efficiently is zone flow technology. Now, this is a Miller exclusive, and what this does is it really allows the operator to maximize that capture zone, taking it from a standard 12 to 18 inch capture zone and maximizing that up to approximately 5 feet away. Now, it does that by reducing an air curtain that acts as a barrier to the weld fume and then creates a negative pressure zone a lot larger than the standard system. And we'll be demonstrating that here live in our lab in just a moment. Advantages of the engineering controls: it mitigates weld fume at the source. Also, again, we're doing this to improve the workplace environment as well as fume capture compliance. And there are a variety of solutions for different applications. Obviously, as we're making a change to the physical workplace, though, there are space constraints. We understand that footprint is a premium. Also, productivity can be impacted because you require that operator to now be interacting with the arm to ensure that he or she is capturing that fume for all their operations. Then, of course, there's consumable costs as well, as the filters do need to be changed out at various intervals depending on your application.
All right, thanks, Marshall. We're going to give you a minute or two to get set up for the live demonstration in the Appleton Weld Fume Laboratory. For all of the participants on the call, if you go to the top right-hand corner of your screen, you'll see the view button.
You can start with your hood up, bud.
If you change your view to speaker, you'll be able to see a closer view of what the laboratory demonstrations will be.
Very good.
Excellent. Thanks, Marshall.
All right.
You can start the live demonstrations at any time.
Great. Thank you, Kathy. Yes, and welcome to our Weld Fume Lab here in Appleton, Wisconsin. We're glad you're here. We want to showcase a couple of products here for you today. And as I mentioned, we're going to showcase two things, really a standard arm versus a zone flow technology, as well as what a fume capture gun is. So first and foremost, we're going to start out with just our standard arm. Again, you can see it's hooked up to our SWX on the wall behind us. That's our stationary system. This arm is connected to a standard stationary arm that I can move and adjust to get within that 12 to 18 inch zone of the weld operation that's taking place. So I'm going to go ahead and start this up. Ben will start his weld and we'll see what that looks like. All right, Ben, you can go ahead and start. And as Ben starts the weld, you can see that I have to move this arm within 12 to 18 inches of that zone in order to capture that fume efficiently. If the operator does not move his arm appropriately, you can see how it will overwhelm his breathing zone. I have to come back and put this arm at that location in order for it to be efficient. Thank you, Ben. So again, that is our standard arm, 12 to 18 inches away. We'll transition over here to zone flow. Now the zone flow technology, again, adds these external fans to the end of the arm. And what that does is create an air curtain that acts as a barrier for fumes and creates a larger negative pressure zone for the normal suction that will transfer into the center of the arm. So what I'll do again is we'll start like a normal arm, simply just with the normal suction. So I'll turn that on and you can see the standard suction, and I'll be within that 12 to 18 inch range as Ben starts. I'll then move the arm away, and you can see how a standard arm will need to be within that 12 to 18 inch, but then I'll activate the zone flow fan so you can see the difference when those are activated. Okay, Ben. So as I'm close here, you see the fume being sucked up into the arm. But as I move this away, maybe it has a larger weldment. It will overcome the space again. So I will turn on the zone flow fan, and you can see now as that air curtain has been thrown out to the side above his head, around the area immediately of the table, and he is able to extract that fume from a lot farther distance away from that table. Thank you, Ben. Now, for those applications where maybe it's not as convenient to have a standard arm, or you don't have maybe the repeated application that you would here in a larger weldment or some of those tables that are going to be stationary for you, you need maybe a confined space solution. Well, that's where a fume gun really comes in handy. So Ben is actually using a fume gun right here, one of our Bernard fume guns. You can see how it has a hose attached to it. We simply haven't been applying the suction through the hose. But now we'll do that for you for a quick demonstration on what that fume gun looks like. We're going to use our Filtair 215 as a suction source. And I'm going to go ahead and Ben will start his weld with this, and I will turn on the 215 so you can see just how much that extraction goes directly into the fume gun itself. So he'll begin his weld again, and you'll see that the fume overwhelms his breathing zone. As I turn on the machine, it will start to suck that fume in, and it will dissipate obviously the rest of that fume production. So he's still welding, but you can see that the actual production of the weld fume is significantly less. It's capturing all of that from his breathing zone. Thank you, Ben. And as I shut down the 215 here, I just wanted to comment to say that machine will allow you to get upwards of 130 foot between different accessories. There's weld fumes, different accessories, nozzles, other things to make it very versatile for you depending on what application you're trying to run. So that concludes our fume demonstration. And again, as Kathy mentioned at the beginning, if there are any inquiries or any customers that would like to see this directly, we'd be more than happy to set up a time with you to do a private demonstration.
Oh, thank you, Marshall. That was great. I know that those demonstrations normally take a little bit longer and get much more detailed information to our audience, but please, if you are ever interested in taking a look more closely at our fume extraction systems, we welcome that opportunity. So thank you for setting that up. So let's go ahead and continue with the next step of the OSHA hierarchy of controls, which is work practice controls. So with work practice controls, this is actually changing the workplace procedures, policies, and the way people work that will enable them to limit or prevent exposures to those hazards. So when we're talking about the welding environment, implementation of best practices on welding technique and the proper use of the equipment, education on the do's and don'ts of the welding hazards itself, proper training in the process, application, and equipment parameters, and workplace procedures of the how to perform a task safely are ways of workplace controls. Now, two key factors in workplace controls is best practices and welding training. In best practices, it's pretty much proper body positioning. So position yourself so that the airflow is moving from your back to your front. Note that there are air movements in the environment that may push fumes into the breathing zone. So you always want to keep your head out of the welding plume. And keep in mind that welding fumes have a natural thermal rise. Proper equipment positioning is also very important. So making sure, as Marshall was mentioning, make sure that the fume extraction arms are placed at a proper distance from the weld source to capture the welding fume efficiently. Now, in welding training, there are key procedures, processes, and policies have been implemented or changed. You want to look at selecting a training program and training solutions that are going to reinforce proper positioning to the welder and to the workpiece, teach them proper techniques that'll keep their fumes away from the breathing zone. Certainly maintaining a stable arc and using the proper gases and teaching the operators how to use that equipment properly. All of that is going to reduce overwelding. It's going to reduce fume generation rates, and it's going to lower the exposure levels. Now, augmented reality training solutions are innovative solutions introduced into the welding industry over the last couple of years. These optimize instructor efficiencies. They reduce overall training time, minimize the material costs, so we're not utilizing arcs and sparks when unnecessary. Also enhances candidate recruiting and screening, allows that instructor to digitally assess and record skill and performance activity. All of these Miller solutions in augmented reality can transform today's students into tomorrow's welders. And that benefits you as an employer to attract, develop, and retain a stronger skilled workforce. Again, with work practice controls, there are some advantages, and that's, of course, proper welding technique and training are going to lead to less exposure, less scrap, and rework, and that's going to increase your productivity and quality. That's also going to increase safety and compliance when there's less spatter and overwelding. Enhancing visibility in a higher quality, higher clarity, auto darkening filter lens can actually lead that operator to higher productivity rates and better welds. Some key considerations is that some of these newer advanced training systems are an investment, and work practices actually require a change in the behavior. That's changing the behavior of the operator and how they work with their equipment and in their environment, and that itself can be a challenge. If you have any questions though regarding work practices, don't forget again to put them in the question and answer box, and we'll address those as soon as we can. So far today then, we provided guidance and the framework of welding fume management, the OSHA hierarchy controls, process modification, engineering controls, and work practices. And now we're going to ask Eric Summers to present the last step of the hierarchy, which is personal protective equipment. And in relation to the welding environment, we're going to focus on respiratory protection today. So Eric, most welding operators today do wear some type of respirator. When is it the right time to implement a respiratory protection program in the welding environment? And what should we know about the selection and type of respirators that are going to appropriately reduce weld fume exposures?
Thanks, Kathy. Really, when we look at respiratory protection, PPE, from an OSHA perspective, that is always the last course of action. Really, they state that when engineering controls are not feasible, while they're being implemented, or when they do not reduce the exposure levels enough, respiratory protection should be implemented. So going through the first 3 steps of hierarchy, maybe it's emitting enough fume that it's not enough from the other controls to get the exposure level below the limit. Once you know that there's an issue, you should be putting the operators within respirators until you can get some of those other solutions worked through. The other thing that needs to be made aware to really anybody that's using respirators, either in a voluntary or mandatory use, is that you really should be, or you need to have at least portions of OSHA's written respiratory protection standard in place. From a voluntary standpoint, anything over a filtering face mask or dust mask needs to have at least Appendix D confirmed and followed within the protection standard. And mandatory use, you're definitely going to expand upon that to the full program. Really anything, again, whether voluntary or mandatory, above a dust mask also needs to have a medical evaluation performed for that operator to make sure that you're not introducing a hazard to that operator, depending on their physical fitness, respiratory demands, etc. Looking at the portfolio of respiratory protection offerings, really start off, a lot of people are very familiar with the dust masks or the tight fitting respirators. Many different options out there, N95, N90 or P100, organic vapor cartridges. So these are going to be primarily within the welding, a lot of particulate filtering, and then in some cases having the organic vapor depending on if there's solvents or anything like that within the environment. Jumping up from there, you're going to go to the powered air purifying respirator or PAPR. So what makes this one significantly different than the half mask is that it actually uses a motor with a battery to pull the air through a filter. And for PAPRs, it's going to be a HEPA filter. Some cases you'll have some of the OV cartridges as well, but it pulls that air through a filter and then pushes that air into a loose fitting head assembly. So with half masks or dust masks, you're using the operator's lungs, diaphragm to pull that air through those filters to filter them out. So once you go up to a PAPR, you're pushing that air into that operator, reducing some of the strain on that individual. As you can see, there's a significant amount of head assemblies available within Miller and within the industry as well to specifically target operators' needs. Going from PAPR, the next step is a supplied air system. So where the previous solutions, the half masks and PAPRs, are filtering out the actual air and delivering that into the helmet, a supplied air system uses compressed air that has been filtered to go through the regulator that is mounted on the operator's waist and then puts that air up within the helmet. Key advantage specifically this week for much of the United States is that you can drop the temperature of the air by up to 50 degrees with some of the models. Our C50 does that. So when we look at tight fitting respirators, diving into those a little bit more, really these are respiratory inlet coverings that form to the operator's face. So when you look at these, you're going to always be fit testing if it's in a mandatory use environment. With that fit testing, that's what's needed to get that, to make sure that you're providing the specific protection that mask is designed for. With any type of respirator, they have what they call assigned protection factor, or APF. With a half mask, you're going to have a protection factor of 10. And what that means is that you can go up to 10 times the permissible exposure limit of a given substance's top limit and still be protected. So you'd reference the actual exposure level of your operators within the environment, reference the permissible exposure limit table that we referenced earlier in the presentation, and then you look at that given substance, multiply it by 10, the permissible exposure by 10, to see if the actual exposure is less than that calculated number. If it is, and you have some factor of safety, then this mask would be appropriate. Next, once we jump to PAPRs and supplied air units, really that covering is going to be more of like a cape seal, partial seal with the face. So what that does is it's more like a head sock with a cinch string on the bottom that put the head assembly on tighten up the head seal, and you're good. These are going to have a protection factor of 25 with a standard head assembly. So going back to our example before in our discussion, you can go up to 25 times the permissible exposure limit with a standard PAPR or supplied air system and still be protected. There are some heavy duty head seals you can see in the middle there. That's more of a cape style that you would tuck into a jacket. And with that, you can actually reach protection factors of 1,000. So significant jump there, depending on the needs of the environment. What's really nice about PAPRs and supplied air systems is that they do not require fit testing. A lot of environments, a lot of welders these days, they've got beards. In order to wear a half mask, you'd have to mandate that those operators shave their beards. So nice benefit for operators that want to keep their facial hair, or also safety directors that do not have to conduct regular fit testing of their operators. Looking at some of the advantages and disadvantages of PAPRs and SARs, really the advantage, the first one, it's delivering filtered air to the breathing zone of the operator. You're taking that burden off of the operator from pulling that air through the filter. We've all worn enough masks over COVID that, in a hot environment that welders are consistently exposed to, you can understand their pain and their struggle of having to wear one of those all day, especially under a welding helmet. You throw a PAPR or supplied air on there, it's pumping that air into that operator. You're not putting that burden on that operator breathing throughout the entire day. With that, on the supplied air, you can drop the temperature by up to 50 degrees, and even the PAPR systems, by just consistently introducing that fresh air within the helmet, helps keep that operator cooler. With that, you can also reduce safety glass and helmet lens fogging. A lot of trip hazards within an environment, welding environment. You've got your ground cables, you have your welding leads. Having a clear view to your work zone is going to help keep that operator safer. And again, these both allow for facial hair that you don't have to shave to get fit tested. Some of the considerations, it is always the last means of protection by OSHA. If you're in a mandatory environment, environment where you are above permissible exposure limits, OSHA is going to want to make sure that you've gone through the hierarchy before you've implemented respiratory protection as a permanent solution. You do need to create a written respiratory protection program. Again, even with a voluntary situation, anything above a dust mask, you're going to have to implement certain portions of that program to be within respiratory protection compliance for OSHA. Consumable costs can add up, just like anything else where you're replacing filters. And then again, even though you're providing that air to the operator, there still is an additional burden on the employee. So you can, when you consider a standard welding helmet versus a helmet with a head seal and air duct and a hose on it, obviously placing that operator in a standard welding helmet with the fume extractor is going to be a little bit more comfortable for them. As well as with respiratory protection, you're only protecting that operator, right? Fume extraction, you're going to be pulling that fume out of the environment. You have production employees, material handlers. That's going to be a wider protection to your facility. And I'll hand it off to Kathy to finish up with the just a quick review of the hierarchy.
Well, thanks, Eric. That was a great review of the respiratory standard and a lot of the requirements that need to be met. And first, considering what type of respirators that can be used for personal protection equipment in the welding applications. Well, we've covered a lot of information today, and I hope it's not overwhelming, but I hope it's really informative. And I hope that we've achieved our goal in providing you with a solid framework and clearing the air and mastering the weld fume management process. But which solution is right for you? Well, keep in mind that this is an ongoing process. And that means going through the OSHA hierarchy is ongoing, and it is actually a collaborative approach, being the best to take a look at, looking at your welding process, the engineering controls, work practice controls, and really personal protective equipment last. Involving your safety, engineering, production leaders is best for a collaborative and successful outcome. Document your progress, successes and failures. Those are the things that are going to determine which solutions provide you the best improvement in reducing fume exposure levels in your specific environment. Every welding environment is different. But our team of safety solutions managers can help you find the best solutions for your environment. Please reach out to us and let us know if we're able to help you with scheduling an assessment of your welding environment. Miller is and does provide a turnkey approach from start to finish with weld fume mitigation. We have the technical expertise, we have innovative systems and solutions, and we also provide product demonstrations and training to support your specific program requirements. We really, truly appreciate your participation in today's session. There are a lot of questions and answers, and Alan, I'm going to turn this over to you so we can start providing some more information to our participants.
Well, thank you, Kathy, and thank you so much, everyone, for this fantastic and insightful presentation. Before we start the Q&A, we want to remind everyone of the evaluation survey we're asking you to complete. The survey will open in a different screen after this webinar, and your input is important because it does help us improve our future webcasts. So our first question is for Bert. What instruments should be used to determine exposure levels?
Well, there are some direct reading instruments that can measure particulate levels, but the direct reading equipment is not specific for any metals. So some of these optical scanners are useful for some procedures, but they're really not good for welding fume. So you have to revert to the classic industrial hygiene method of using an air sampling pump attached to a filter. And I remind you, the filter has to be in the welder's breathing zone. OSHA in their manual procedures require that the filter be placed under the welding helmet. So you're measuring what the fume level is under the helmet. That does not apply, of course, to a papper. You're not supposed to break the seal on a papper. In that case, you can only measure the fume level outside the hood.
So our next question is for Kathy. Do used filters need to be managed as hazardous waste because of the contaminants and heavy metals collected on the filter? Kathy?
I apologize, I was on mute.
That's okay.
Sorry about that, Alan. Yes, the recommendation is to follow your local EPA regulations for disposal of hazardous materials, since we are treating welding fumes as a hazardous material to exposure. So in regards to disposal, you'll need to follow your local EPA requirements for disposing of hazardous waste.
This question is for Marshall. How comfortable is the fume extraction gun? Is it a different complete welding unit, or are there certain attachments? And can I buy it to outfit existing Miller MIG or MIG units?
Yeah, thank you. It's a great question. I'd say that the fume guns are more bulky in terms of the lead or the hose, just because it does have that hose around the normal lead. However, we find that operators really get used to them once they start using them. And there's some other opportunities that you can add in to help alleviate some of that strain. So the perceived strain relief of a standard gun is very comparable to that of a fume gun. And Bernard offers a variety of those. They actually have a pretty good configurator out there, so you can see what's available for various machines.
This question is again for Marshall. Does the 215 machine come with a filter, and how often does it need to be changed or cleaned?
Yes, the 215 does come with a MERV 16 rated filter. And that filter, it depends on obviously your applications, what you're running, and the amount of hours usage. We estimate somewhere in the neighborhood of 3 to 6 months. It could be up to over a year, depending on how intermittent the machine is used. But it does have a self-cleaning system inside that allows that filter to be actually cleaned by compressed air. Oil-free, clean, dry, compressed air. It's hooked to the front of the machine, and it will pulse after use, and it will help clean that machine, essentially dislodging that particulate into a disposal tray. So it does extend the life of that filter up to 8 times compared to a traditional non-clean system.
This question is for Eric. What maintenance and documentation is required for a PAPR?
All right. So with a PAPR, even in voluntary situation, before you place any of the operators within them, you do need to complete the basically the medical evaluation questionnaire. Again, that's in the written respiratory program from OSHA. It's about a 6-page questionnaire, making sure that the operators are fit for use to use a PAPR or SAR. Once that is cleared, at that point, you want to do training. Training is mandatory, and you should be documenting that each operator that is using any type of respirator has received their training. Annually after that, you do need to conduct training as well. Part of that training, each day that operator should be looking at that unit, taking a look at the hose, head assembly with the head seal on it, making sure that there's no holes, perforations or anything like that. They do come with PAPRs, an airflow indicator. It's a clear tube with a little ball within it that you put in the end of the hose and turn the unit on and make sure that the ball floats up from the airflow and it's at or above the minimum airflow line on the indicator. And then also just double checking that it does go through the warning process. So if at a certain point the filter gets loaded up too much, you have some obstruction, PAPRs are designed with a alarm device for the operator. So you just want to do a quick function check each day, and then annually making sure that the training's being completed. After that, it can really depend on the environment, on the filter change out. That's really going to depend on filter load from the amount of fume within the air.
Our next question is for Kathy. What would you say to a customer that would rather use a PAPR or SAR instead of investing in the correct fume extraction unit?
Well, what I would say to that is, the OSHA hierarchy of controls is a proven method of looking at all of the facets of your welding environment. So as it states, the respiratory protection is the last step that should be considered. Now, if engineering controls are not feasible, they can't get an arm within the proper placement to extract the fumes away from the individual, or the fume guns are not able to go into the weld joints to extract fume away. If those things are not feasible to be able to be put into the environment, then yes, they can use PAPRs and supplied air, but that step has to be evaluated and documented first.
Our next question is for Bert. When addressing an exposure with a contractor that suggests welding outdoors is an effective engineering control, what should be requested to verify compliance on keeping exposures below the PEL?
Well, proper positioning is obviously important. If you're doing any welding outdoors, you have to position yourself, if possible, so that the natural ventilation provided by being outdoors is drawing the fumes away from you. And let me just piggyback on that previous answer. I've been involved with a company for several years that has to do monitoring for hex chrome because OSHA does not consider respiratory protection an adequate solution to the welding exposure.
Our next question is for Marshall. Can the air curtain be added to any models or to a specific one?
That's a great question. Yes, that zone flow technology is available on our standard arms. So essentially our 10 or 12-foot arms that then can be attached to a SWX unit or one of our centralized systems. It also is available on Capture 5. It's just a little bit different. With that system, it uses the cleaned air and supplies that back out. So it does not have external fans, but it produces the same technology and the same result. And that's the Capture 5 mobile system.
Sorry, I'll throw a question out to the group. When welding inside a confined space, how many air changes per minute are required?
This is Bert. Let me take a stab at that one. Obviously, there's a lot of variables. It depends on the size of the confined space and how much welding you're doing. It could be very little, or it could be depending on a lot. Again, that's where you should have a industrial hygienist assess the situation in person to give you a more concise answer. In
Also,
other
another
words, there's no fixed number.
Also, another question, perhaps for you, Bert. What are minimum natural ventilation requirements to safely remove welding fumes?
There's a rule of thumb that goes way back when I started industrial hygiene. You should have 1 cubic foot per minute of general ventilation in any kind of facility per square foot of floor area. So if a building's 10,000 square feet, you should have 10,000 CFM general ventilation. That's a minimum requirement. And of course, again, depending on how much welding is going on, you might need additional ventilation on top of that.
I think we had a couple more technical questions about kind of as coming off the demonstration. What kind of power, volts, or amps are needed for your systems?
I can take that. I think for our demonstration, what we were using was our standard arms as well as the zone flow. And that requires essentially a 220 to a 110 system. So 110 will drive the external fans, and you can run the actual system that cleans the air. Again, the SWX can be hooked up to various powers as well. So very versatile for the application needed.
Is that the same for the zone flow technology?
Yeah,
Like
that's correct.
Okay.
The zone flow technology, those external fans actually run separate, and that is a 110 system. So
Okay, the question for Marshall, how do you know what type of fume extractor is best for your facility?
it's a great one. We could talk all day about that, but it really is, again, based on the application that you're doing. Oftentimes we'll see repeated areas. So a stationary system that's for maybe like a training center or a school perhaps that needs that repeated small capture area where maybe a stationary arm will work. Even a telescopic arm that's a little smaller. You don't need a whole lot of space. They're doing a repeated operation. That's a prime candidate for a static or stationary system, especially our centralized systems that can be placed across a wall or into various weld booths per se. When you get into the larger fabrication environments, and those mobile systems are really designed to be versatile, to be able to move around the shop and get to a location, or be able to extract fume from various locations around a larger weldment, let's say. Those are great for being able to move throughout the facility and capture fume as needed at certain different locations. And then again, the high vacuum systems are really designed for those unique environments where maybe they're used to fume guns already, existing users that are using fume guns, or those areas that are more confined spaces, or say a maintenance operation that's done at height, where again, a traditional arm and extraction system just won't reach. So when you need that reach and that versatility, that's where the high vacuum systems come in great.
I think we have time for one more question. Bert, how often should you have your air quality assessed?
Excellent question. I've been told by numerous attorneys, for example, any data that's older than 3 years is really not worthwhile anymore. So I've been telling people for years that at a minimum every 3 years assess it. Of course, if the process or materials change, you should have it assessed more often.
Well, thank you, everyone. Unfortunately, we have run out of time today. I want to thank our awesome presenters, Bert Schiller, Kathy Abshire, Marshall Legg, and Eric Summers. Also, thank you to everyone at Miller, and of course, a big thank you to everyone who attended today's event. Take care and have a safe day.